Okay, we'll continue on with lesson 4.1a, looking at solving equations. So I've done all the work for us here, so we'll talk through some of these. So here are three different equations. You can see they get more difficult as we go from A, B, and C. This is a one-step, two-step, and a three-step equation. And again, we use the same techniques we use to solve a linear equation. Just at the end, we end up taking the square root. So looking at these three here, this is just a square root, and then remind yourself that you're always going to end up with two solutions, the plus and minus part. Since negative times a negative equals positive, we have two solutions on these problems. Divide both sides by 3, and you end up with getting to these points here. Here again, multi-step, subtract 100 first, then divide by 5, and then take the square root here. I don't know what times what mentally, what times what equals 40. And so then you need a calculator. And again, Desmos is allowed. So I would use Desmos to simplify these expressions here. Square root of 40 equals 6.325. Now we have a little bit more difficult situation here, just in terms of because of the way it looks, the numbers. And so a classic quadratic equation is the area of a circle, the formula. So to find the area, how much space is inside of a circle, its area is equal to pi times the radius squared, or whatever the radius is multiplied with itself times pi. If you don't recall, or just to remind you, again, pi is a number that never ends, so it's approximately 3.14159. Pi was discovered when someone measured the distance around a circle with its radius and found this pattern that this number always existed for every circle. So that's where it comes into play in an area of a circle. And so if the area is 300, what is the radius is a classic question in mathematics, finding the radius when you know the area. And so with this, I would, next step here, divide both sides by pi. I treat pi as a variable because I don't want to write its number 3.14159 because it's never ending. So we use a symbol, the pi symbol, to do that. And so pi's would divide, you'd end up with this here, and then you take the square root of 300 divided by pi, which I'm showing you here. This is what it looks like in Desmos. And you would end up again with the plus or minus. And in this case also, remember, although there's two solutions, technically radius can't be negative, so the true solution would just be 772. You got to remember the context of the problem. We're looking for the radius. And then there's two more problems where we apply quadratics is when we're looking at stopping distances of a car. So when a car is moving and they measure its braking distance or measure a skid, you can then determine how fast the car was going. And so here are two examples here where we have this quadratic equation that represents, again, the distance a car takes to stop given how fast it's driving when it stops. And so what we have here is 120 is the feet to brake, and then we can solve for the velocity, how fast the car was going. You could see my steps. We end up, and then here are my calculations from Desmos over here on this side. So then you can see where I get those numbers from. And then it ends up, again, not miles per hour, but it's feet per second, 74. You end up only keeping the positive because of speed we're talking about. So we know the answer was 74.595 feet per second. And then what happens if we go from 120 to 240, double our braking distance? What happens to the speed now? There is the solution for that here. Again, you can see my math after the initial setup. 240 gets substituted in for D. And then you have the process of solving them again. And you can see it's not miles per hour, it's feet per second. You only keep the positive part.